3 o'clock in the morning, you're exhausted, but your brain has other plans. The same conversation keeps replaying, the same mistake, the same worry. You know nothing is chasing you, nothing is happening, yet your heart refuses to believe it. Now imagine explaining that feeling to a wolf, or a chimpanzee, or your dog sleeping peacefully beside the bed. Could they understand what it's like to be trapped inside your own thoughts? Probably not. And that raises a question that's far stranger than it sounds. Did evolution give humans a mind so powerful that it also made us the only species capable of completely losing touch with reality? For centuries, madness was treated as a mystery. Some cultures blamed spirits, others blamed curses or moral failure. Today, neuroscience paints a very different picture. But before we get there, there's one discovery that changed how scientists began thinking about the human mind. In the 1970s and 1980s, the World Health Organization coordinated one of the largest international studies ever conducted on schizophrenia. Researchers expected enormous differences between cultures, different diets, different religions, different lifestyles, different healthcare systems. Instead, they found something unexpected. Schizophrenia appeared in every population they studied. The exact numbers varied from place to place, but the disorder showed up with remarkable consistency across humanity. That was difficult to ignore. If a condition appears in virtually every human society, regardless of culture, researchers have to ask a deeper question. Why has evolution never removed it? Natural selection is remarkably good at eliminating traits that consistently reduce survival before reproduction. So why would a condition as devastating as schizophrenia remain part of the human story? There isn't a single answer, but several scientists have arrived at an idea that keeps resurfacing from different directions. Maybe the vulnerability isn't separate from what makes us human, maybe it's connected to it. That sounds backwards. Evolution is supposed to solve problems, not create them. But evolution has never aimed for perfection. It settles for what works well enough. A peacock survives with feathers so enormous they make escaping predators harder. A giraffe reaches the tallest leaves, but its heart has to pump blood nearly 2 meters upward every second of its life. Every advantage comes attached to a cost. The human brain may be the most expensive trade-off evolution has ever made. Before we explore what that cost might be, here's something I'd like you to think about. Have you ever caught yourself arguing with someone who wasn't even in the room anymore? Don't answer yet. Keep that thought in the back of your mind. Because it turns out that tiny habit and one of the most serious mental illnesses known to science may begin with the very same ability. And that changes the question completely. That question has fascinated evolutionary psychiatrist Randolph Nesse for decades. Nesse argues that many things we call mental disorders aren't simply broken systems. Sometimes they're protective systems that fire too often. He explains it with what he calls the smoke detector principle. Imagine a smoke detector that never gives a false alarm. It sounds perfect, until the one day there's a real fire, and it stays silent. A detector that occasionally screams because you burn toast is annoying. A detector that misses a fire is deadly. Natural selection doesn't reward perfect accuracy. It rewards survival. Your brain works much the same way. For most of human history, assuming the rustle in the bushes was a predator, even when it was only the wind, was usually the safer mistake. False alarms were cheap. Missing the real danger wasn't. That ancient threat detector is still running today. The difference is that lions rarely wait outside our homes anymore. Instead, the system scans emails, conversations, relationships, the future, even our own memories. That's why your body can react to an embarrassing moment from 10 years ago almost as if it's happening again. The danger isn't outside anymore. Your brain learned how to create it from the inside. But this only explains anxiety. It doesn't explain something much stranger. How does a brain go from worrying too much to believing something that isn't real? To answer that, we have to look at something that quietly shaped our entire species. Anthropologist Dunbar spent years comparing the brains of primates with the size of the social groups they lived in. Again and again, one pattern appeared. Species living in more complex social groups tended to have larger brains. His conclusion was simple, but its implications were enormous. The human brain didn't become unusually large just to make tools. It became unusually large because people are incredibly complicated. Every day your brain keeps track of who can be trusted, who might be lying, who owes someone a favor, how another person feels, and then something even more remarkable. It tries to imagine what they think about you. That ability is called recursive thinking. Thinking about someone else's thoughts, about your own thoughts, No other animal appears to do this on the same level humans do. It's one of the foundations of empathy, language, cooperation, civilization itself. Neurologist V.S. Ramachandran has argued that the extraordinary expansion of human social cognition and systems involved in understanding other minds helped separate us from every other species. But complexity has a price. A bicycle is easy to repair. A modern jet engine contains thousands of parts. The more sophisticated the machine becomes, the more ways there are for something to go wrong. The same brain that lets you read sadness from a friend's face, write music that hasn't been heard yet, or imagine a future that doesn't exist, is also a brain capable of seeing patterns that were never there, of assigning meaning where none exists, of mistaking imagination for reality. And that leads to one of the most unsettling questions in neuroscience. What if madness isn't the opposite of intelligence? What if it's one of intelligence's side effects? We'll get there. But first, there's another piece of this puzzle that almost sounds like science fiction. It begins with a parasite and a house cat. The story begins with a parasite so common that millions of people carry it without ever knowing. It's called Toxoplasma gondii. Most healthy people never develop symptoms, but what caught scientists' attention wasn't the illness it causes, it was the way it changes behavior. In rodents, the parasite does something extraordinary. Healthy mice instinctively avoid the scent of cats. Infected mice often lose that fear. Some even become strangely drawn toward it. For the parasite, that's a perfect strategy. If the mouse gets eaten, the parasite reaches the cat, where it completes its life cycle. It's one of nature's strangest examples of behavior being influenced by biology. Psychiatrist E. Fuller Torrey spent years exploring whether something similar could be happening in humans. Several studies have found that people with schizophrenia are, on average, more likely to show evidence of previous exposure to Toxoplasma gondii than the general population. But there's an important distinction. This doesn't prove the parasite causes schizophrenia. Many people carry the parasite and never develop the disorder. Many people with schizophrenia have never been infected. The relationship remains an active area of research. Even so, it forces scientists to ask a fascinating question. If something as small as a parasite can influence behavior, how much of what we call the mind depends on biological systems we barely understand? By now, a pattern has started to emerge. Randolph Nesse points to survival systems that can become overactive. Robin Dunbar shows a brain that expanded to manage incredibly complex social lives. V.S. Ramachandran argues that our uniquely human brain evolved by repurposing older neural systems into something far more flexible and powerful. Different fields, different questions, yet they all lead toward the same possibility. The human brain didn't become fragile by accident. It became fragile because it became extraordinary. Think about what your mind does every single day. It imagines tomorrow, it replays yesterday, it invents stories, it predicts other people's reactions before they speak. It wonders what happens after death. It can even stop and examine itself while it's thinking. As far as we know, no other species spends its life inside that kind of mental world. And perhaps that's the point. The same machinery that allows imagination also creates the possibility of illusion. The same machinery that allows deep empathy can become overwhelming. The same machinery that lets us build civilizations also leaves room for confusion, obsession, and in some people, devastating mental illness. The brilliance and the vulnerability are woven into the same design. Remember the question from the beginning, the conversation you replayed at 3 a.m, the argument with someone who wasn't even there. That wasn't your brain malfunctioning, it was your imagination, memory, emotion, and prediction systems working together, the very abilities that helped our ancestors cooperate, survive, and eventually build everything around us. Sometimes those systems become noisy. Sometimes, for reasons scientists are still trying to understand, they become profoundly disrupted. But they're built from the same architecture. Before you leave, I'm curious about something. Which idea surprised you most? The smoke detector principle, the social brain, or the parasite research? Tell me in the comments. I'd genuinely like to see which one changed the way you think about the human mind. And if you enjoy exploring the strange places where evolution, neuroscience, and human behavior meet, subscribe. There are plenty more questions hiding in plain sight, and some of the answers are even stranger than this one. Because the real mystery was never why the human mind can break. It's why a species evolved a mind powerful enough to ask that question in the first place.